Welcome back to the Open Source Startup Podcast. I am one of your co-hosts, Robbie from Cowboy Ventures, and joined, as always, by my co-host, Tim Chen from Essence VC. And today we're super excited to have the CEO and co-founder of Generally Intelligent on the platform, Kanjun. And she's going to go into way more detail about what Generally Intelligent is, but it is essentially a platform to build general AI agents in a very safe way. So welcome, Kanjun. We're so excited to have you.
Thank you.
Awesome. So let's start by going back to where the idea for Generally Intelligent came from.
Yeah. So I was running a different company at the time with my current co-founder, Josh. It was Sorceress, an AI recruiting company. We had gone through YC, we raised our Series A, and we actually lived in this big house. Some of our housemates were building GPT-3 at the time. They're the first authors. And so we were seeing like, oh, this is in 2019, I think. Scaling is working. Seems like these things are learning these general representations of the world. And so, maybe there are really interesting things that these models can be used for. And Josh and I have always been really interested in the idea of general agents. For me, it comes from thinking about human creativity. Like, I really deeply believe in human creativity and potential. And I think like generally when humans are free and safe and psychologically healthy, they'll like generally do good things by and large. And so we're very optimistic in this way. And so I think we're very inspired by the Xerox PARC kind of personal computing revolution, this idea that the personal computer can be to people something that kind of changes our way of thinking, a deep tool for thought, and also changes the way that we live. And I think the personal computer has not fully reached its potential yet. If we think about our day to day, our days are mired in execution day in and day out. Like we're moving things from here to here. And it's like, when I'm on my computer, I'm like all in, all executing all day. And I think we're so in it that we have forgotten that the computer is actually in our way. And there are many ways for the computer to not be in our way. The least of which is like for it to understand us and to help us do things, as opposed to for it to just be here and for us to like have to like try really hard to get it to do what we want. And so Josh and I have always been very interested in agents for this reason, because agents are things that can understand us and help us do things in the digital world and maybe eventually in the real world. And so that's where the idea came from. We started Generally Intelligent in the idea happened in 2020 and the company really formed in 2021. And the reason was because we felt it was the right time. Self-supervised learning was working, scaling laws were beginning to work. And we really felt like, if we begin to work on agents now, then it's not going to be 20 years. It's going to be maybe 5 to 10. And so that's why we decided to start at that time.
So maybe you can help explain, because I think from what we can understand from maybe the TechCrunch article or your blog post, there's not a lot of information really about the lab, because it's really branded as a research lab, but also has funding as a company. And we've seen OpenAI sort of more from this open-ended research into even more like a product company. So can we talk about like the intention of a research lab, and maybe what are some of the goals you're trying to achieve? Is it eventually also to build products and to become that side of the world, or is this purely trying to motivate as a fundamental research lab?
Yeah, definitely we want to build products. I think the way to impact the world and to impact people is to build products. I think though that there is a right time when the technology is ready for product. So if OpenAI had tried to productize in 2016, it wouldn't have worked. They would have shipped a product that didn't make any sense. I think Apple actually does this very well. They have a pre-development phase that is research, technical research, where iPhone was in development for 10 years, AirPods for many, many years. And there's a time when the technology starts to get ready, and that's when they're prototyping and really trying to make internal demos that work. And that's kind of where we are, where the way to think about agents today is we're in a world where people are very excited about generative AI, and I'm very excited about it. I use it all the time to brainstorm and help me help me think about things and rewrite titles and all of that stuff, write social media content. And generative systems really do understand the world, kind of like really do learn good models of the world because they are given so much data. Their task is to predict the next word. And it turns out that the best way to predict the next word is to model the underlying generators of the words on the internet, which is humans and the world around us. And so, I really do believe that these models are quote unquote intelligent in that way, and they don't make for good agents. I think if you try using them as agents today and you see these cool Twitter demos of AutoGPT pretty quickly, like if I'm trying to use it myself, what I realize is it's just not very good at doing things. It has bad judgment, kind of like a person who's read the entire internet but never done anything in the world. I would expect that person to have pretty bad judgment. And these models do. And so we are very interested in systems that can know certain things, know how to do certain things, and know how to take actions that make sense. For example, just to illustrate, like a really simple example, one of our team members was scheduling a team offsite, and she was trying to find a time. She found a time, everyone worked. And then a person a week later was like, oh, I can't make it anymore. She's like, okay, let's move it, found a new time. And then someone else is like, oh, I can't make it anymore. She's like, okay, I'm not going to find a new time. We're going to relax the constraint that everyone has to go, because it's going to be really hard to find a time that everyone can make. And so the question is like, when would a language model push back on you and tell you that your goal needs to be changed and that you need to relax this constraint? There's a whole set of skills that we call reasoning that are needed in order for this to happen. And that involves like knowing what questions to ask and what the goal is and when to relax constraints and things like that. And we work on reasoning. So we train foundation models optimized for reasoning in order to make it possible for agents to work at all, and to be able to do these longer chains of reasoning and to be able to kind of do like a tree of thought style, like branching out, and for things to work after several steps. So we really focused on that. And on the reasoning side, we kind of initially focused on code. So to your question of product application, I think long term, it depends on how the technology shakes out and what type of thing makes sense, whether it's a platform, whether it's individual agents that end up getting productized, but there will be a product.
Yeah, I think it's so interesting because the space is evolving so quickly. And I imagine even when you started, there is a little bit less buzz than there is now. And so I wonder, like, what were when you initially started Generally Intelligent, what were the initial kind of set of milestones that you wanted to prove out? And because this is a different kind of way to build a company than some of the founders we have on here, where it's a very like kind of more cookie cutter in a way of like building a company of release product one, then you add on this product or you release it. Like this is a kind of a unique way to build a company. So what did you focus on early on, and what were some of the early milestones that you wanted to achieve?
Yeah, so early on, we were very interested in can we get agents that can automatically by themselves learn things about the world and figure out what actions to take without having to hard code in the reward function. So we were working with reinforcement learning. And so at that time, what was happening was that a lot of reinforcement learning environments, multitask reinforcement learning environments, so that's any environment that has multiple tasks that you have the same agent doing, many of those environments were like an outside third person view of like a robot arm moving a thing, or of something going on in the environment. And also they tended to have hard-coded reward functions for the agent. So what that meant was that for each task, like open a door, the agent would get a reward if you like hit the handle and then turn the knob and then open the door. Like the human is putting all of our knowledge into the agent. And we were not interested in that. We were interested in, can the agent, like what does it look like for the agent to have to learn things on its own without us putting our knowledge in? And how possible is that? And so we built this environment, Avalon, that we actually decided to open source because there was a lot of kind of demand from others. And we built it so that we could explore. It was meant as a scientific environment so that we could explore, okay, if we take a bunch of different reinforcement learning systems, how well do they do in this environment of many, many tasks? So Avalon is this open world environment, 3D, imagine like Minecraft, but super fast. So we thought about using Minecraft, but it's like super slow and very difficult to control, kind of a curriculum of difficulty. So one of our hypotheses was actually, if you start with simpler things and the agent is getting reward faster early on, then they will slowly actually learn the more complex things. And this ended up being true, where, if you start with eat and the food is right in front of you, then you can move randomly and then end up with the food. And then you move the food farther away and it kind of learns to slowly, move farther away and eat the food. So that's what we were interested in initially. And what we learned was actually these systems are quite good at solving a lot of these tasks. It learned how to climb. It learned a few sequences, like how to open doors, but it's very bad at planning. So anything where it has to make a decision about what to do, like go here or go there, or anything like that, like really bad at reasoning through that situation. And so that's how we got to reasoning, actually. This was like in the middle of last year. And we started to see, language models are potentially actually beginning to be useful for reasoning. And there was actually really good work by Chelsea Finn at Stanford, who was on the Generally Intelligent podcast. She did work called SayCan, where she did reasoning for robotics in natural language and then had the robot take the action once it figured out which action to take. And that's when we began to really seriously explore reasoning and also seriously explore a real environment like your desktop or your code editor.
Awesome. That's really, as you know, we all have been trying to figure out what the AI advancement is really like right now for everybody involved. And you're definitely in the forefront with your work. And you've been working on agents probably longer than most other people is in the wild right now. Because right now, AGI, agents, even sentient, these words are coming out all the time now, which is, I think jokingly, we see these words out, but at the same time, agents are definitely becoming more true. Like people are starting to see there is a possibility to be used in some situations. And I wonder, how do you define progress for yourself to say, I want this? Like you said, you talk about planning, right? You found reason. It sounds like this is like an exploration process for you, but is there defined milestones? Like, let's get this environment to able to achieve something or achieve certain metrics so we know we're on the right path? Or this is pretty open-ended, just to able to capture any possible things that we never seen before? I just wonder, how did that work internally for you guys?
Yeah, we're actually quite focused. It's not like, we call ourselves a research company because research still needs to be done. We don't have a product yet because it's not ready yet. But at the same time, it's not like open-ended research. We're very focused. And in particular, the way it works is that we train our own foundation models, so large models, and we kind of basically take this idea of serious use from interface design very seriously. So serious context of use is the idea that, you don't want to build demos that you're not really trying to use. That's what a lot of these Twitter demos are, because it doesn't teach you the true capabilities of like what is possible, what's not possible. And it doesn't force us to like duct tape the system to try to make it better so that we can actually use it and make it work. So we use our models internally right now in a serious context for code, because we write a lot of code. It would be amazing to have something help us write code much faster. That's our primary bottleneck. Code is also a really good environment, type of task to do, because code seems to be helpful for reasoning and also seems to be helpful for taking actions. So we measure our own success with a suite of internal evaluations, so our own kind of benchmarks, and also external evaluations and subjective evaluations of our own experience using these agents ourselves. And we're very focused on basically like make the foundation models better so that they're better at reasoning, so that these agents work better on all of these evaluations.
And I want to talk a bit about the research environment, Avalon, and why you decided to open source it. Like, what was kind of I imagine that there was a discussion, or probably multiple discussions that your team had around the pros and cons of open sourcing it. Can you kind of walk us through how you thought about that?
Yeah, we always viewed it as a scientific environment. There was never a world in which we'd build product using this environment. And what we were hearing from researchers that we were talking to, and also researchers we interviewed on the Generally Intelligent podcast, is that there wasn't a kind of the main thing missing in reinforcement learning and blocking progress was good benchmarks that allowed people working on much more general methods to showcase their progress, the kind of like abilities of those more general methods. So for example, some people who are interested in exploration or planning, if you have a really limited environment that's not open-ended and doesn't have much harder tasks and doesn't scale up to much harder tasks, you actually can't show that your planning algorithm works better or your planning model that's good at planning works better because the environment doesn't require planning. Same with things like curiosity and things like that. And so we wanted to open source it so that other people could actually make progress on these problems that seemed like really limiting in reinforcement learning. And it was just one of our environments. It's not something that we were planning to use permanently. The other thing is like there were a couple other problems that it was solving. Like Minecraft is slow. It's 5 frames per second, which means that you have to train an agent for a really long time. Avalon's about 100 times faster than Minecraft, which means that like in a single unit of time, you can train the agent for 100x more steps. And so we were able to make a lot more progress using Avalon than with Minecraft as a result.
I see. That actually makes a lot of sense because most people when they learn about AI, especially the software engineers getting to AI, the OpenAI's gym has been really helpful for you to just replay a bunch of skeletons. I play with it before. Every single MOOC out there and all these things reference that, right? Download the gym, get the SDK, use the open source. I think that's a really good way to get people, help everybody to leverage and learn together, but also have the brands be built that we are in this environment and we're constantly pushing the state of the art. And I guess a few questions in my mind. Maybe I'll start with this because obviously when you build an environment like Avalon to help you able to train and do experiments and learn from an RL model, now you're trying to also make progress on this coding agents. I wonder, how do they complement to each other? Are these like separate experiments that run through different parts, or is this actually a parallel effort? I'm not sure I know if there's any connections between your coding product with Avalon at all.
Yeah, so Avalon was a way to kind of inspect a bunch of things for us. So for example, we were very interested in this idea of automatic hyperparameter optimization. We kind of felt like a lot of these networks, they're not well tuned. It's really hard to do science when you don't tune your network, because if we make a change, is it working better because we didn't tune our baseline, or is it working better because it's actually working better? So we actually recently released Carbs, which is a automatic hyperparameter optimizer, and it's really awesome. It basically finds the Pareto front of cost and performance. And what happened with Carbs is that we ran it, trained many small language models, and it automatically reproduced the chinchilla scaling laws. You just hit go and it reproduces those scaling laws because it found, at each given cost, like these are the best hyperparameters, you should have this amount of data, etc. And Carbs came out of Avalon because we were trying to train these reinforcement learning agents, and in this environment with like lots of different parameters that were configurable, we were like, okay, well, it would be great to automate this process of what we're already doing, which is try an agent, run it for 50 million steps, then run it for 500 million steps and see like how much better does it get, and then tune the parameters that like we just automated all of that. And now we use Carbs internally for training much larger models and scaling, deriving scaling laws automatically for all of these models. So kind of out of Carbs, because we get the Pareto front of cost and performance, we can see at each cost, okay, what are the hyperparameters at that cost? And as we increase cost, so as we make it train for longer or for more GPU hours, what are the hyperparameters that are optimal at each kind of training length, training cost? And then you can kind of plot, okay, well, these hyperparameters, go in this direction, and this one goes in this direction. You want to increase the number of heads, you want to decrease the number of layers, whatever it is. And that's an example of something that came out of being able to do science in Avalon. There are a couple of other learnings that came out of being able to do science, like being able to conclude like, reasoning here, hierarchical RL doesn't really work. to be able to draw that conclusion, I think would be tough in a normal environment where we couldn't control all the parameters. And also, I think this is maybe a little bit controversial, but we think curricula matter. Like that was a huge learning from Avalon, like with no curriculum, where you don't start with the easier tasks first. Like none of the baselines learn anything. With a curriculum, the baselines learn how to like climb and open doors and all these things. And it turned out that like well-tuned PPO is the like, canonical best RL algorithm, but very simple, no world model, nothing like that. That actually performed super, super well when it was well-tuned. And we also tuned PPO on ProcGen, which is an OpenAI benchmark that the team, John Schulman, who released PPO, released ProcGen. And we had using carbs, we tuned PPO and found that PPO solved most of ProcGen and really outperformed the original release PPO on ProcGen. And so, it really went very far to say like, wow, tuning really matters. And I think those are a lot of the big things we learned from Avalon. And we bring a lot of that into our work on reasoning, but it's not necessarily like in research, you don't want to get attached to your projects. Like projects are for learning. And so we try not to like stay attached to Avalon if it's not useful as an environment right now.
Yeah, and it seems like a major goal across the company is really just learning as much as possible so that you can keep having these breakthroughs on how you can actually create better and better agents over time. I want to talk about a bit of a different side of the business, because one of the biggest holdups to a lot of generative AI companies today is the cost of just operating, because it's quite unique compared to just like a typical SaaS company. And I think from everything I've read, you've been super savvy about fundraising and thinking about that side of the business. Can you talk a bit about how you thought about that and just like the funding structure for the company? Like you were able to attract just like incredible caliber of investors. There's a lot of links that folks draw between what you're doing versus like early days of OpenAI and DeepMind. And so just to the extent of how you've thought about that side of the business, because I think that's when we've seen a lot of founders in this space, a lot of them don't think about like, okay, a lot of what we're trying to do is super costly. And you just put a lot of thought into that, which I think is like a strategic advantage for sure.
Yeah, that's true. We definitely knew from the very beginning that this would be very expensive. On public record, we've raised $20 million. And, we've raised from very long-term thinking folks who know that the agent product is going to be incredibly powerful and compelling. And that is really going to change everything. How we interact with computers, what they're able to do. And it's not ready yet. And they know that. And so... and it's going to take, more capital to train larger models. So I think we are very fortunate to be backed by investors who are kind of thinking longer term like that.
It's a very amazing opportunity, but you definitely have to have a long-term horizon to this, right? Because I think it sounds like just like the OpenAI journey that we see, it seems like you have a focus, but where it will lead to, it's actually I feel like it's actually quite still open-ended, right? And I guess I wanted to ask you, because the goal is to release products. And what we learned from the outside is OpenAI, definitely was from a research turn to products. And the product was just more of a demonstration, right? And it turned into a big hit. And now we see a lot more sort of like AI companies coming to do some, definitely has like a very product focus, but you have to also be very grounded in research just because the space is moving so fast. And I wonder, how do you decide what is the kind of people and direction you want to be taking on into your company? Because it feels like you can't have every different kind of philosophy and stance into the team, right? You definitely want to be trying different methods or trying different philosophies, but I believe there's probably some kind of thinking around, okay, this is what we generally believe as a company or a team. And we want to be able to align. Everybody that joins believes in a certain level of way of working together that brings different pieces together, but probably also like has a different strengths. I just wonder, how do you decide how to assemble a team like this? Because it can't just be any researcher, right? Or any AI person. And especially when you have a small team to start with,
Mm.
I think it's definitely a very big challenge if figuring out what is the right kind of people that should be working in a company like this. Like, what have you learned on trying to build a company like this with a team structure and culture and just like alignment with that?
Yeah, I think we have a very unusual culture, and it's not something we talk about very much, and we're hoping to talk more about it in the next few months. But I really believe in people as creative agents. So I think a lot of companies, they're very proud of thinking of their people as assets. And when I think about assets, I'm like, this is such a low bar. Like, what is an asset? It's something that you own that provides value to you that you can discard at any time. You can sell it, you can trade it, you know? And people are not that. Like, people are not these fixed objects. And so we really believe in treating people as creative agents. I think our team culture reflects a lot of what we hope to see in the world, where people feel very safe, very trusted. The interview process is quite arduous, but then after that, you know, we really trust is given. And I really try to help people find their superpowers and understand what they are and really be able to focus on them. So something we talked about last week, one of our team members was like, man, I'm really happy that our other team member, Bartosz, is like super loves infrastructure and like doesn't want to work on coding agents. And like, all I want to work on is coding agents and I super hate infrastructure. And that's kind of the type of dependency, honestly, that I really believe in. Like, we're a team, we should depend on each other. We depend on each other to have superpowers in different places than where we have. And so when I think about building a team, like, I really think about diversity in this really strange definition of diversity, I guess, is not what people normally mean. It means like really trying to find people who spike in areas that we don't have right now, or in areas that are unusual. And then when they come in, we really try to unlock what they have to offer and really unlock their creativity. So most of the projects that we have, really everything that we've made progress on, was because of someone's creative impulse. And so that's like to, you know, everything from, we have like really, really, really nice homegrown infrastructure that lets us run experiments really fast and is just like super nice, doesn't fail all the time, etc. All the way up to like, you know, the way that we build carbs. Like, carbs was one of our team members, Abe, being like, I think if I spent like 3 weeks on this, I could just solve this problem, like automate all of the research I'm currently doing of like parameter tuning. And those are just two examples. Like, also our head of talent, Nick, she did the design art direction for Avalon. So, you know, Avalon's really beautiful, and it's because of Nick. She picked all the colors. Nick also, you know, determined a lot of our brand. And that's not something a normal head of talent would do, but it's because of the way that we think about people as like, I don't believe in fitting people into roles. I think like people kind of carve out their own blob inside generally intelligent, and they like kind of grow it over time and really try to infuse their own creativity into it. And so when I think about, like, you know, at the beginning I was like, oh, I really believe in people's creative potential and humanity's creative potential, and I really want to enable that. Like, this is a small microcosm of what that's about. So that's how I think about team building. I think like more concretely, it's like, okay, we are very engineering heavy. We have a few researchers, but a bunch of researchers, I guess, but all of them also do engineering. And we really believe in doing science, being able to run clean ablations, having like really good, reliable, fast infrastructure so that we can iterate really fast, learning really quickly from experiments. Those are some important core beliefs.
Yeah, it's really amazing. And I can imagine that it creates this real sense of ownership over what the company is like ultimately trying to achieve, which I think is really incredible. I'd love to hear what some of the biggest unlocks have been. Like, what were some of the major milestones where like you were able to get an agent to understand X, and like that just ended up being just this like huge, like, oh my God moment for the team?
So to Tim's question earlier, you were asking about approach and kind of the, you know, all of the players in the ecosystem. And our approach is, we really believe training the foundation model is very important. And it's because the agent is doing stuff that generates data that can be fed back into the foundation model, and not just fine tuning, but like training from scratch. And like, we really think the data is really important. So some of the interesting unlocks have a little bit to do with like, oh, training on this data was very surprising, or and like resulted in very surprising things. Or we also spend a fair amount of compute at inference time. So having models talking to each other, like a kind of a family of different models talking to each other, reasoning through a situation where certain models are optimized for maybe asking questions, and other models are optimized for evaluating things. That also is very surprising, just seeing the agent succeed on things that I wouldn't necessarily succeed on, where I thought it made a mistake, but actually it was right. There are a lot of situations like that. Also situations where it does something surprising. It like generates code that worked. And not just one-shot generated code that worked, but because it was thinking through a set of things, it like ended up making a set of decisions that let it generate code that worked. I think it feels really magical to have a thing that's just in the background, kind of like doing a job that I otherwise would have to do. So that kind of thing, when it works, is very surprising. It works very rarely, which is why for a certain type of task, for like very simple tasks, it actually works pretty well. But for any task where I'm like, okay, I actually would get a ton of value out of this task, it works very rarely. And when it works, it's very surprising and awesome.
Got it. So I kind of want to jump into maybe more like just a general agent question, because from what we see as we're investors and looking out the spaces, like this word agent definitely comes up a lot now. Like there's a ton of agent-based experiments, but also agent-based companies now. Agent-based IDs, agent-based a bunch of things, right? And code is actually fairly commonly seen as one of the first products as well. And for lots of obvious reasons, most folks don't have that extensive experience actually working in this space, like what you guys have been doing for years. And I think we definitely seen the really amazing capabilities for GPT-3 and GPT-4, and that's just assuming we're just going to get better. Now we're just kind of building on top of what we exist today. It's a very open, and I think where everybody's trying to learn together what are all the limitations of how do you actually build agents. Is there anything from your side, given you've been in this space for so long, what is really the hardest part that you think this is, you don't have to talk about many details, but like generally, what is the hardest part building agents and trying to bake it into like a production like environment? What are like the hardest areas you think most people haven't even thought about, or even this is going to be something everybody has a thought through, that you can't just use GPT-4 and break it down tasks, and that's kind of it. Like, what are the hardest part you think you've encountered that is really worth mentioning?
Yeah, you're not going to like the answer. The hardest part is making them work. But we have a very clear thesis on why they don't work, and that's why we focus so much on reasoning. So to us, reasoning is a whole bunch of different things. It's like knowing when to ask questions and knowing when to clarify the questions and being able to project out what's going to happen if I do this. Okay, that's not the right thing to do. I'm going to roll back. I'm going to do this instead. It's also kind of being able to hold context between different situations. So like a type of thing that GPT-4 is bad at today is if you have code that spans 5 files and you have to hold context across all 5 files, it's very difficult for it to do that for clear reasons. And that's a type of thing that if you want to make that work, you have to do slightly different things. Yeah, so I think like actually making agents work is harder than we think it is. We're going to start seeing, but the way I think about agents is it's not binary, it's a spectrum. So we're going to start seeing simple agents that work in simple ways. And we already see that today, and we use those today. We have like a really nice linter agent that's like going around our code base linting stuff and fixing type errors and things like that. Those are very trivial agents and useful. And then we'll probably see agents that can do upwork tasks. You specify something that's very clear, and then agent can do it. But the ceiling is really high for agency. Can it, help me figure out how to spin up a new product. That is a very difficult type of project that probably, we won't have agents that can do that for a very long time. And so, I think about it as the capabilities can always be increasing along this spectrum, and they get more and more and more advanced. And a big part of how the capabilities advance is about reasoning and being able to reason about a situation and be able to go find information that it's missing and process that and update its own understanding of the situation and things like that. That's going to allow us to unlock a lot of these bigger use cases. Even for software engineering, some of the simple code use cases work, like I said, the linters, but more complex things, internally we start to see, okay, here are the limits of some of the more complex things. How do we solve for those? And then there are like super complex things like, Josh, my co-founder, just shipped like an 8,000 line change to our infrastructure. And it was like a big refactor of the infrastructure. To have an agent do that well, I'm just like, ugh, it's going to be hard to do that for a while.
And what is the philosophy of shipping? Because right now, I think you have so far has open source projects, right? There's no externally usable product per se, but I think a lot of startups typically are like, okay, let's maybe just get the linting to work because that's where the agent capabilities is at, right? So let's ship that something like MVP, right? Make it work. Everybody can use it. Maybe you can use that to like collect data, and that can actually help you maybe to work on the next thing. Is that mindset of an MVP iterative approach is what your team tries to do? Or, hey, or the other side might be like, hey, this is what the state of the art we see outside today is. Let's at least break through at least certain capabilities or certain percents or something like that. Then we ship. What is the philosophy of product that you would like to ship from the company?
Yeah, so this is where we think about serious context of use. We ship a lot internally. And the reason we ship internally is because we believe the underlying technology doesn't necessarily have this nice smooth gradient from it works as a linter all the way to it works as like an agent that can refactor a bunch of my code base. And the things that work as a linter right now, like if I need to go sell that product and support it, it really detracts from being able to work on the next set of things. The other thing we notice is that users adapt really well to these tools. And so what happens is if the agent can't do certain things, the user is not going to try harder things. And so getting stuck is a very large possibility. That's why we try to push them constantly internally, because internally we have easy tasks, we have hard tasks, and we're always trying the harder tasks because we know that's what we want them to do. At some point, we'll probably ship something. It's not, super clear. At the moment, we're not quite sure what that's going to be because it really depends on how the technology shakes out. What's easy to do? What's hard to do? Is it easy to make my own agent, or is it really hard? And that's going to impact what we end up building.
So I want to go back to something you said and then ask a bigger question about your thoughts on the industry. But from my side, and I assume Tim's side too, we are seeing a lot of pitches and promises from founders building highly capable agents in different functional vertical areas and infrastructure stack. From your perspective, do you think a lot of these are way overhyped and like the space is a little bit too overfunded right now, given where the research is and what is actually possible?
It's probably the case that some of these products don't work at all. Some of these products probably work some, and that might actually be enough for their customers. It feels a little bit like early mobile, where we had tons of party apps, and then we had like tons of apps that tried to do certain things, but maybe they didn't work that well. And I think the question remains to be seen, is it the right thing to do to start acquiring customers and have a thing that only works some of the time and that's good enough and we just keep improving it from there? Or do you come out with something that is good and like is better, and then kind of grow it and improve it, like is set on a good foundation? What I see with people using these agent products is there are a lot of people who try it and then just drop off because it doesn't work that well. And, I think there will be a day when enough people try it and don't drop off that like retention is good. I think like GPT-3 Playground was an example of a lot of people tried it and just dropped off and then didn't use it for a while. ChatGPT is an example of people tried it and like some dropped off, but like enough people got use out of it that it went crazy viral. And I think the current agent products are probably more like GPT-3 Playground, where a lot of people might drop off, or there's a lot of work needed to get each use case working, and it is a little bit brittle. But there will be an inflection point at which it feels more like ChatGPT. And it feels like we're, for most use cases, probably not there yet. And Generally Intelligent, at least, is very interested in a much more general purpose platform where we can have many use cases and many use cases that take off.
So do you have any advice for founders that are building an AI agent-based startup right now? Because we're definitely seeing a surge of them at the moment. So what's the number one advice you would give them if they're just starting off? They have technical backgrounds, they play with GPT-4, they have some prototype, okay, we can build some product out of it. What would be the number one thing you would tell them?
Join us.
So abandon your ambition and come be part of the cooler ship.
Yeah, because I think having control over the foundation model is really important. I think a lot about where are the moats in this space going to be. And I think there was a time when, in the last 10 years, like distribution was the hardest thing for startups. If you build something, they won't come. You have to figure out how to distribute it. Very occasionally you get lucky and it becomes viral. Here, what we're seeing is basically if the capabilities are strong, are awesome, then people will come. It does go viral because the capabilities are so crazy. And so distribution, as long as the capabilities are there, is not such a big issue today. And so I think, if you're building on top of something like GPT-4, you're trying to build agents on top of GPT-4, it's plausible that you'll build a good business, but very open question mark as to whether there's any moat there long-term, because everyone else can also build on top of GPT-4. Whereas, I really believe like we're building the underlying foundation models and underlying capabilities, and that is ultimately what is going to drive a lot of the value. So, and a lot of the moat. Like if you think about Midjourney, a lot of people in the beginning were like, Midjourney has no moat. They're just using diffusion models, which are public. Anyone can build diffusion models. And I think it's actually quite remarkable. Like Midjourney has a pretty good moat and a lot of revenue and a lot of usage. And the reason is because, David Holtz, the CEO, has done a really good job imbuing a particular set of capabilities into those models where the aesthetic is really nice. It's exactly what you wanted. It's beautiful every time. You put it into Stable Diffusion, the same prompt, it does not generate something nice. And that is a moat. Like people use Midjourney because it's a much better product and the underlying capabilities are much stronger. And that moat is in the capabilities of the model because the model generates something that is, high quality for the user. So that's something, for these other founders to think about.
This was a fantastic podcast. I think anybody who's building in this space, at a company building in this space, founding a company in this space is going to find this super useful. So thank you so much for joining us, Kanjun. We really enjoyed it.
Thank you so much, Robbie and Tim. This is super fun.